This is chapter 9, section 1. In this section, we're going to determine if a real number is rational or irrational, and we're going to understand the meaning of radical expressions. So just as a reminder, we're going to be talking about integers. So just to remind you that integers are whole numbers, the number 0, and their opposites. So all of these are examples of integers. So we're going to talk about the difference of rational and irrational numbers. A rational number is any number that can be written in the form a over b, where both a and b are integers or whole numbers. Okay, so if you get a decimal, it's a decimal that ends. But basically, any number that can be written in fraction form is a rational number. An irrational number, however, is a decimal that goes on and on and on forever, and it doesn't repeat. For example, the number pi, 3.141592 ... is a number that goes on and on and on forever. It never repeats, and it never terminates. So we're going to look at the difference in rational and irrational numbers today when we're talking about perfect squares and perfect cubes. All right, so on your note paper, you should have the first 20 perfect squares. So a perfect square is any number that, it's a number you get by multiplying two of the same number. So 1 is a perfect square because 1 times 1 is 1. 4 is the next perfect square because 2 squared is 4. 9 is the third perfect square. 16, 25, 36, 49, 64, etc. So when you're doing some of the problems in this chapter, it's very convenient for you. It's easier for you if you recognize perfect squares. So if you automatically know that 64 is a perfect square, then that's going to help you a little later on. All right, so just a little bit of vocabulary. So this sign right here, this is called a radical sign. A number under the radical sign is called a radicand. So if I wrote 25 is the radicand, and the entire expression is called a radical or a radical expression. So I'll be using those terms throughout chapter 9. All right, so since you have your first 20 perfect squares written, then hopefully you recognize that all of these are perfect squares. So the square root of 36 is 6. The square root of 4/9, we can also think of this as a square root of 4 over the square root of 9. Well, on your list, you see that 2 times 2 is 4, so the square root of 4 is 2. Square root of 9 is 3. And letter C, the square root of 64 is 8. Now, I do want to show you on a calculator, because if you have this calculator that we've been talking about all semester, this does a lot of this work for you. So for the first one, the square root of 36, you have a second button right here. You'll hit the second button. And then above the x squared button, you have a radical sign. So if you'll hit that, and then on your calculator screen, you can see it comes up. So if I want to know what the square root of 36 is, I just type in just like that. I hit the enter, and it tells me the answer is 6. All right, so even if I have a fraction, I'm going to start with my second button. I'm going to go with my, above the x squared button, I have the radical symbol. And then I'm going to type in my fraction, so n over d, my fraction button. I'm going to type in 4. I'm going to arrow down, put my 9 in, hit enter, and you can see the answer is 2/3. Okay? So if you get used to using the radical button, that helps you. It's going to save you a lot of time. In a few minutes, we're going to be looking at the cubed roots. So to get the cube roots, above the caret button, there is an X outside of the radical symbol. So we're going to use our second button. Let's say we want the cubed root of 8. So since I want a cubed root and not a square root, I would start with the number 3. Now I'm going to hit my second button, and now I'm going to hit the caret button because I want the cubed root of 8. So did you see how that 3 turned? It went very small right there. If you have a regular size 3, then that's not the cubed root. It's 3 times something. All right, so the cubed root of 8 looks exactly like that on my calculator. Then I hit enter, and the answer is 2. It's hard to see that a little bit. There we go. All right, so anyway, we'll get to that in a few minutes. Now, letter D, this is basically asking, what is the opposite of the square root of 49? Well, the square root of 49 is 7. The opposite of 7 is negative 7. So letter E, you can think of the square root of 100 over the square root of 121. Square root of 100 is 10. Square root of 121 is 11. And then go back to the original answer. It's asking what's the opposite of that? Well, the opposite of 10 over 11 is negative 10 over 11. And then letter F, I'm not really sure what the square root of 4.41 is, but I'm going to just put it in my calculator. I'm going to hit the second button. I'm going to hit the x squared button because I want the radical above it. I'm going to type that in, 4.41. And it tells me the answer is, can we see it? 2.1. 2.1 is a terminating decimal, so 2.1 is rational. That's a rational answer. It's not a perfect square. Well, I guess it is a perfect square because 2 times 1 times 2.1 is 4.41, but it's not a whole number. All right, now let's look at these 3 problems, however. Now this is asking, this is not on the outside. The negative is not on the outside, it's on the inside. So basically this is saying what number times itself equals negative 36? Well, we know the answer is not 6 because 6 times 6 is positive 36. So then we think, well, what if it's negative 36? Well, negative 6. So is negative 6 times negative 6 negative 36? Nope. If you square a negative number, you'll also get a positive number. So this is actually a non-real number. If it asks you for the square root of a negative number, the answer is non-real. It doesn't exist. So when you get into college algebra, you'll deal with non-real numbers, but not in this unit, not in this course. So the answer is just simply non-real. Letter H is asking for the square root. If you don't see a number there, it's always an assumed 2. It's asking you what is the square root of negative 4/9. Well, since there are no numbers that multiply to give you a negative number, this answer is also non-real. So if the negative is outside the radical, it is a real answer. But if it's inside and if it's a square root, the answer is non-real. Letter I is asking what is the opposite of the square root of 64. Since the square root of 64 is 8, the opposite of 8 is negative 8, which is a real number. All right, so here is a note that I have that you don't have on your paper. It says the square roots of negative real numbers are not real numbers, which is what I just showed you, like G and H. They're asking you the square roots of negative numbers. They are not real numbers. Thus, the square root of negative 4 is not a real number, and the square root of 25 is not a real number. Such numbers are called imaginary numbers or non-real complex numbers. These numbers and their properties will be studied in later courses in math, not in this course, however. All right, so now we're going to look at some numbers that we can simplify that are not perfect squares. Now, if you just plugged the square root of 20 in your calculator, you can see that it is a non-terminating decimal. So anytime you have the square root of a non-perfect square, it is an irrational number. So since 20 is not on your list, 14 is not on your list of perfect squares, and 60 is not on your list of perfect squares, it means that all of these answers are irrational. Irrational numbers are real numbers, but they're not integers. They're not rational numbers. Okay? They're irrational numbers. Now we can simplify irrational numbers though. So one way we're going to do that is if I want to find the prime factorization of 20, I want to know what two numbers can multiply to give me 20. Well, I can start with anything. 2 and 10. 2 is prime. 10, the two factors of 10 are 2 and 5. And now these are all prime numbers. So remember when I told you if you don't see a number, it's automatically a 2. So basically, it wants to know how many pairs of numbers could we break this down into? Well, we could break it into 2 times 2 times 5. Well, if you imagine that's a 2 right there, it wants to know I need 2 of every kind of number. Well, I have a pair of 2s. Since I have a pair of 2s, that means I get to pull out 1 2 outside the radical, and inside the radical, I get left with a 5. Another way of thinking about it is, think about the number 20. Are there any perfect squares that are factors of 20? Yeah, so 20 is 4 times 5. Well, 4 is a perfect square. What's the square root of 4? Square root of 4 is 2. So you can think of it that way. Think of a factor of 20 that's a perfect square. Find the square root of that number. Or break it down into the prime factorization. Circle every pair of numbers you get and pull one of them out to represent 2 inside the radical. All right, let's look at letter K, I should say. All right, so 14, the only two factors of 14 are 2 and 7. And those are both prime numbers. I can't break it down anymore. So basically, when I break down list of prime factors, I don't get any number that I have a pair of. So my 14 has to stay under the radical. It doesn't have any factors that are perfect squares. However, 9 would be 3 times 3. Wasn't the square root of 9 3? So my 9 would be simplified. The square root of 9 is 3. And so this fraction would be simplified in this way. My numerator is still under the radical because it doesn't have any factors that are perfect squares, but the denominator is a perfect square. So the denominator is just an integer now. All right, now letter L. Now this is going to be a real number because it's asking what's the opposite of the square root of 60. So I'm going to think of this as a couple of different ways. I want to think, okay, well, what two numbers multiplied give me 60? So I can start with 2 and 30. 2 is prime. 30 could be 2 and 15. 2 is prime. And 15 is 3 and 5. All right, so 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So I know I have the right prime factorization. So now I want to look for so let me write this way. 2 times 2 times 3 times 5. All right, so I'm going to pull out all of if I have a pair of numbers, I pull out 1. So I'm going to, since there's 2 2's, I'm going to pull out 1. And what's left under the radical? 3 times 5 is 15. And don't forget, it was the opposite of this answer. So that's my final answer. Okay? Now, it's important that you know how to do all of those. However, if you have this awesome calculator, it does all of that for you. Now, that doesn't mean you don't need to know how to do that, because when you get to cube roots, this calculator won't do that for you. All right, so let's say I want to start with the square root of 20. I'm going to hit my second button, plug in 20, hit enter, and look, that's exactly what happened. I got 2 square roots of 5, which was my answer. All right, square root of, oops, I messed that one up. Square root of a fraction. I'm going to put 14 over, arrow down, 9. Then you can always get out of that by arrowing to the right. And it tells me Oh, no, it didn't do that one. So this is another one that you have to know how to do, because even though this is the best answer, it doesn't want this answer in decimal, so I have to do it that way. That's why even though your calculator is a great resource, you still have to know how to do this, because it will do some of them and some of them it won't do for you. All right, and then finally, the opposite of the square root of 60. And it tells me my answer is -2 square roots of 15. Okay? Now, also on your paper, I included the list, the first 10 perfect cubes. So 1 is a perfect cube and a perfect square. 8 is, because 2 times 2 times 2 is 8. The next perfect cube is 27. The cubed root of 27 is 3, because 3 times 3 times 3 is 27. So on and so forth. The next number that's both a perfect square and a perfect cube is 64. So like I said, if you can recognize at least a few of these, up to maybe probably 125, I would say, 5 cubed, it makes problems a little faster for you later on down the road. All right, so it says if A and B are real numbers such that A to the third power equals B, then A is called the cube root of B. The cube root of B is A. We write it like this. It looks just like if it's a square root, but if it's a third root, it will always have a 3 there. If it doesn't have a number there, that automatically means the square root. All right, so since you have your list of perfect cubes, you see that these are all perfect cubes. So what number times itself 3 times is 8? The answer is 2. 2 is the cubed root of 8. The cubed root of 64 is 4. The cube root, now this one, we have a negative under the radical, and you may want to say, well, that's a non-real number. However, since 6 times 6 times 6 is 216, let's check to see, is -6 times -6 times -6 a negative answer? Yes, it is. -6 times -6 is positive 36. And positive 36 times -6 is -216. So this is a real answer. The real answer is -6. All right, and then finally D, we could think of that as the cube root of 1 over the cube root of 27, and we would get 1/3, because those were both perfect cubes. All right, now, if you read the directions on these tell you that you have to round these to the nearest thousandths. Now, these problems you have to do on the calculator. I could show you how to do it without a calculator, but there's no use in it, because your calculator, no matter what calculator you have, it will turn all non-perfect squares into a decimal. So you're just going to simply use your calculator, plug it right in there. Make sure you use the square root. If it's asking you for square root and cube root, you want to use your cube root button. All right, so basically the square root of 15. Now on this calculator, it automatically leaves it as this because it doesn't have any factors that are perfect squares. However, if you want to turn it into a decimal, because that's what the directions say, above the enter button, there's a double arrow button. You're going to hit the double arrows, and it will turn your answer into a decimal. It says the nearest thousandths. So the 2 is in the thousandths place. So you're going to look to the right of the 2, which is a 9. And a 9 turns a 2 into a 3. So this answer is 3.873. The next one is asking what is the square root of 7. Double arrow button, and the answer is 2.646. 2.646. Letter C is asking what is the opposite of, so we're going to use our negative button, the opposite of the square root of 23, and it tells us negative square root 23, so then I hit double arrows, and I have negative 4.796. Okay, now it might also give you those with cube roots, so you would do it the exact same way. All right, just here's a note for us. It says the fundamental principle of rational expressions in general, if a is a positive real number, then the square root of a is a real number. However, the square root of negative a is non-real. The square root of a is rational if a is a perfect square, like the square root of 25, square root of 36, or the quotient of perfect squares, for example, the square root of 4 over 9. Otherwise, if the number under the radical is not a perfect square, the answer is irrational. All right, and some of these I got from straight off of Hawks. So now, even though this section only deals with perfect squares and perfect cubes, when I looked in the Hawks, it had a 4, the fourth root of. So if you have one of these calculators, or any calculator will do this, I believe, you're going to basically do it the same way. So since there's a 4 in there, I'm going to start with the number 4, and then I'm going to do my second, and then I'm going to do above my caret button because I want the X in front of the radical. And now my 4 turned real small. Do you see that? And then I'm going to type in my fraction button. And I want to know what is 16 over 81. I'm going to right arrow out of the radical. And my answer is 2/3. 2/3. All right, now number 2. Just so you know, a radical sign and a square always cancel each other out. So this answer is just 3. But just to be sure, we're going to plug it in our calculator. So I'm going to type it in exactly like I see it. So I'm going to type in my parentheses, my negative button, my square root button, 3. You got a right arrow, get out of the radical. Now end your parentheses, and now I'm going to do my x squared button right here, x squared button. Now I'm hitting enter, and the answer is 3. So the opposite of the square root, so basically it's saying so that's the problem, right? So basically we know a negative times a negative is a positive. We know the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So that'll help us later on when we think about that. A square root and a square, they always cancel each other out. And you know a negative times a negative is a positive. So that's why this answer is 3. All right, so then look at number 3. In Hawks, you'll have numbers like this, and the question will be, is this rational, irrational, or non-real? Well, since I don't see a number, it means it's automatically the square root. So the square root of a negative number doesn't exist. So this answer is non-real. If it was just the square root of positive 38, 38 is not a perfect square. So the answer I would pick would be irrational. If it was asking me the square root of 36, the choice I would choose would be a rational number. All right, and then number 4, once again, they asked me the fourth root. So I'm going to start with a 4. I know this is so hard to read. My second button, my square, caret button. And then I'm just typing in there 256, 256. Hit my enter button, and it is a integer. It's a rational number. So this is just 4. And then number 5 is just a calculator problem once again. I'm just typing it straight into my calculator. -5 plus 7, and now I'm doing my square root button, square roots of 2. So it should look exactly like the problem on your paper. And then when I hit enter, it gives me the same response exactly like I see it. So since it says round to the 4 decimal places, I hit the double arrow button, and that is my answer. It's 4.8995 because the number after the next 4 is a 9.